Welcome to another walkthrough in SPSS. This time we're going to be talking about how to calculate validity, and we're also going to be talking about calculating validity using various techniques. So you're going to notice that a lot of the techniques we use to look at validity are very similar, or in fact the same techniques we'd use for reliability. So whether we're looking for reliability or validity is not the statistic, it's the purpose of why we're looking. So if we're simply looking to see if a test measures the same thing at the same time, then we're looking at reliability. So for example, test, retest, or split halves. However, if we're comparing one test to an existing test or a behavior pattern, so let's for example say that we have data that includes our measure of anxiety, but we also have a behavioral measure where people self-reported anxiety, and we also have an observational measure where in a lab we actually noted the number of anxious behaviors. We'd expect there to be a relationship between our new measure of anxiety, self-reported anxiety, and observed anxiety. So in that case, we'd be still looking for correlations or regressions, but instead of actually looking at it from a viewpoint of reliability, we're now looking at a viewpoint of validity. So whether you're looking at validity or reliability has more to do with what variables you're looking at, what you've done before you ever open SPSS, and what the actual question is that you're asking. Like with all these SPSS walkthroughs, I strongly suggest that you download these slides and have them available for your references, both when you're doing homeworks in this class, but also for other classes as well. So if we're going to compute concurrent validity, concurrent simply means that we're looking at validity that is happening concurrently. In other words, we're not using time or a delay. We're not predicting someone's behavior based on a measure. We're simply comparing similar measures. So the example I just used in the last slide would be an example of this. We brought someone in, we asked them how anxious they are, and then we gave them our anxious scale. That gives us two variables. We'd expect there to be concurrent validity. In other words, it's one participant, but they're giving us scores on multiple ways of measuring the construct. And then we're determining, is there a strong relationship between our measure, our construct, our test, our assessment, and other measures that are considered valid as well. So we're going to go to Analyze, Correlate, Bivariate. And you're probably very used to this screen now. This is the same screen we've used for most of our actual reliability tests as well. So in this case, for example, I could bring over time 1 and time 2 or whatever it is. So here we actually have what I've brought over is a new version of a measure and an old version of a measure. So again, time 1 and time 2, that's simply whatever it is. That's basically just whatever the variables are that you're looking at. And we're going to choose the two variables, our new measure and any variable that we think it would be related to, and we're going to bring them over from the left-hand box to the right-side box. Once again, we're going to make sure that the Pearson's correlation is clicked, the two-tailed test is clicked, and flag significant correlations is checked. Those should be set in the default, and we're going to click OK. And we're going to get an R, and we're going to get that significance, and we're also going to get our N, the same thing that we've gotten with previous tests when we've looked at not predictive validity, reliability. So this gives us our concurrent validity coefficient. So notice that it's still R, 0.795 in this case, and our significance is less than 0.001, so we will report that as less than 0.001. Once again, we never report a P of 0. And that's going to be, in this case, it's still R, but instead of us calling it a reliability coefficient, we're now calling it a validity coefficient. And this lets people know what we're doing. And we'd actually probably state this in our results as there was strong evidence of concurrent validity. Our measure was highly related to measures or to a previous measure of the same construct. If we want to compute predictive validity, so again, concurrent simply means we're just going to gather multiple measures of the same construct and see if they're related, correlated. For predictive validity, we're going to give the assessment and then later on see if that assessment predicted a valid outcome. So for example, if I was looking at life satisfaction, I might want to see, do people that have higher levels of life satisfaction actually perform better in therapy? So my predictive construct is the measure of life satisfaction. My outcome is success in therapy. We use predictive validity a lot in actual employment and industrial organizational settings. So I might give an assessment that is meant to predict how well you'll perform in the job. Predictive validity in that case would be the assessment, and then months later, I would actually look at performance. Did my assessment predict who would perform well? So in this case, we're going to need to run a regression instead of a correlation, for regression gives us information about prediction. So we're going to go to Analyze, Regression, and select Linear. Once again, we're going to click on our outcome, what we're predicting. So for example, in this case, I'm looking at college GPA predicted by ACT. So if you applied for college, there's a good chance you took either the SAT or the ACT, which is supposed to be a predictive test of how well you'll do in college. It's not a perfect test. People who score very high on the ACT usually do better in college, but not always. And people who score lowly on the ACT typically do poorer in college, but again, not always. There's other factors, including motivation and other forms of intelligence, obviously. So in this case, though, I want to do a predictive validity check. So I'm going to go ahead and I've got two scores. I've got the person's ACT, but also in this case, I also have their college GPA. So they've been in college at least for a semester to where I have a GPA, possibly much longer. So I'm going to click on the outcome, what we're predicting, and bring it over, and I'm going to bring it then, and I'm going to bring over what I actually expect to predict, and I'm going to bring that over to the second box in the dependent variable. Once we've clicked on your predictor, ACT, and bring it over to the independents, we've got those both in, we're going to click OK. Notice again, the default here should be enter, and that's fine as long as you're actually looking at a bivariate regression. In other words, you're simply regressing one predictor on one outcome. So again, we have some information, a little bit more with regression than correlation. So we've got the R squared and R. This is basically explaining how good of a predictor it is. So for example, in here, our R squared is 0.026. It's predicting 3% of the variance. Not very good. The R is 0.162. And again, we're going to look down here and see what we're actually looking at. And we've got our constant score, we've got our B weight score, and we've got our significance and our test score. Now, the significance and test score is always going to be actually the row that has your predictor. So don't look at constant. Constant is simply a prediction of what your predicted variable would be, GPA in this case, would be if your ACT score was 0. That's where we start. So that's the only information that that's giving us, and it's almost always going to be significant. We're not worried about that. What we are worried about is ACT, is it a significant predictor of GPA? In this case, it isn't. So for every score, every positive point on ACT, it increases the GPA by negative 0.03. So there's actually a negative relationship in this case with this particular data set. This isn't, by the way, an indication of the actual relationship between ACT and GPA. These were two variables that I simply randomly assigned to this for the purposes of this experiment. In reality, ACT is a predictor of GPA. It's just not a very strong one, but it's one of the best ones we have, and that's why we use it. So in this case, again, it's not significant. If I wanted to actually calculate again, if significant, then I could create a prediction equation. In this case, I would take the constant, which in this case is 3.598, that purple box. I would add the B weight times the predictor score. So again, what is your score in the ACT? Multiply that by the B weight, add it to the constant, and that is going to be the prediction of that person's actual GPA. We also talked a few lectures ago about the multi-trait, multi-method variance, a way to look at basically validity. It looks at both convergent and divergent validity at the same time. We can actually do the analysis for this in SPSS. So we talked about how to interpret a multi-trait, multi-method convergent and divergent validity table, but let's talk about how we actually create one. So we're going to start again with Analyze, Correlate, Bivariate. So this is going to bring us to a very familiar screen. In this case, though, we're going to bring over multiple predictors. Now remember that the multi-trait, multi-method matrix is based on the idea that you're looking at different ways of measuring different traits. There should be two methods of measurement. So for example, one might be a pen and paper test, the other one might be observation. And there needs to be both traits you'd expect to be related and traits that you're not. In other words, trait A and trait B. So in this case, for instance, I might have a pen and paper test of anxiety. So that's method 1, trait A. And I might have an observation of anxiety, method 2, trait A. Then I have a pen and paper evaluation of history knowledge. That would be method 1, trait B. And then I have an observation of people's behaviors with history and knowledge of history. In other words, maybe an oral evaluation. That would be method 2, trait B. So again, I really want to stress that SPSS is going to provide us numbers no matter what we put in this box. This is up to us to know what we're doing. We need to make sure that we have 4 different variables that vary both method and trait. Once we have those, we're going to bring them over. Once again, make sure Pearson's clicked, two-tailed test is clicked, and flag significant correlations, and click OK. And that's going to give us this table. Now, this table also gives us information about what's going on. So red is the actual just reliability. That basically is our indicator that, for example, a variable, basically a same method, same trait, is related to itself. And it should be. It's the exact same test. What we're most interested, though, in is the trait scores. So this is the trait by 2 different methods. So in this example, I've got extroversion and agreeableness, self-report versus other report. So if we look at extroversion self versus extroversion other, we see a R of 0.932. If we look at agreeableness other and agreeableness self, we see an R of 0.845. Those are the 2 green boxes. And that's the measurement of trait. That provides reliability and validity information. We're seeing very similar scores of the same construct measured in 2 different ways. The blue boxes represent the method variance. In other words, we can now estimate some of the error. So what amount of explanation of the scores is based on simply the same measure or method. So in here we have self-report, and the blue box, 0.004 at the top, represents the same method, self-report, on 2 different constructs. And here we have very strong evidence that it's not the method that really is coming up with it. People are coming up with very different scores depending on what construct's being measured. We see a little bit stronger on other reports, so how others see us, 0.128, and we'd actually expect that a little bit because others also tend to have a little bit of a halo effect when they watch our behavior. They already have an assumption of who we are, and that's going to show up in error. And finally, we're going to have the purple boxes, and that's basically should be the lowest correlations. And this is an example of divergent validity. It's showing us that if we use different methods on different traits, we find the smallest values. So if we're looking at evidence of both concurrent and validity and reliability with the multi-trait, multi-method matrix, we'd expect the red boxes obviously to be high. They should be actually 1.0. The trait should be the next highest. The method should be the 3rd highest. And the purple boxes, which is basically heterogeneity, in other words, difference, they're completely different from each other, should be the lowest. So again, if we think back to the actual multi-trait, multi-method matrix, we're going to again see that idea that if we're using the same method and the same trait, that's going to be basically 1.0. We're not worried about those numbers. What we are looking for, though, is evidence of validity and reliability in those T's, and we're looking for actually evidence that there isn't reliability or isn't variance shared in the M's and the H's. So again, hopefully this gives you some further ideas of how to use SPSS as a statistical package to conduct a lot of the analyses that we're talking about in this class.